Hi everyone. Okay, I have shared my screen. I hope you can see it. I'm not sure if it is visible. Let me reshare it. I think we can start now. Okay, so let's just start. Okay, so welcome to the tutorial on neural networks using Keras with Tensorflow. I'm Anil Sharma. I'm currently a PhD student at IIT Delhi, and let's just see what we will be learning in this tutorial. Okay, so what we will be learning today is about neural networks. We will first see an introduction to the neural networks, and then we will see how to code neural networks in Keras with the TensorFlow, and then we will see how to train a neural network for cat and dog classification. And then we will be using some pre-trained models, and then we will be fine-tuning an existing model for image recognition. For example, cat, dog classification, mask, no mask classification, face, no face classification. Those are the tasks that we can do use by doing fine-tuning an existing model. And then I will leave you with a take-home exercise where you can perform cat dog classification or mask no mask classification using Keras. So basically, I have divided this presentation in two parts. Today we will see only these three sections, and then tomorrow or maybe day after tomorrow we will see how to use pre-trained models and how to do fine tuning, and then I will like leave you with the take home exercise. So basically, like, I have divided it into two sections, two parts, because in the earlier tutorials I have got feedback in which people suggested that please cut short the presentation a little, because earlier presentations were going more than an hour and it was like very difficult to maintain the attention span. So that's why I have divided it into two parts. Today we will just see the first three sections, and in the next tutorial we will see the next three sections. The next tutorial will be either on Thursday or on Saturday. Okay, we will inform you. Please join our WhatsApp or Telegram group so that you will keep updated with these things. So before proceeding with the tutorial, I just want to make clear that what this lecture series doesn't include. So it doesn't include theoretical introduction to deep learning. Rather, it is more practice oriented and will help you to learn how to code neural networks. There will be no evaluation of the take-home exercise, and there will be no certificate. Okay, so what you should already know for this tutorial, that you should be strong in Python. If you don't know Python, I would suggest you to refer some online tutorial or maybe email me. I will give you some references. If you have some basic knowledge of deep learning, that will be helpful. So tools that we will be using in today's tutorial is Google Colab for coding. I will be showing you how to code neural networks in Python. Okay. Alternatively, you can also use Jupyter Notebook or PyCharm or any other platform that you feel comfortable with. We will be using Keras with TensorFlow to implement our neural networks. It's a user-friendly toolkit to implement deep neural networks. So let me just show you. I think these are common. Maybe I will show you these things live after the presentation. Okay, so before proceeding with the with implementation of the neural network, I would like to tell some introduction about the data, like how to set up the data and how to use the data set in neural networks. So basically, data is nothing but collection of maybe collection of images, collection of some other kind of data, maybe text, maybe some signal, maybe some other form. Okay, so basically, let's say if we have a few categories, let's say airplane, automobile, bird, cat, deer, and so on. Okay, so what we will be having is, for each category we need to have some data. So data could be an image. So this is a CFAR10 data set where there are 10 categories. Okay, and for each category there are images associated with it. So for example, for airplane, there are various kinds of images. For automobile, there are various kinds of images. So like why I'm telling you this is that like in neural networks, what we need to do is we need to use a training set and the testing set. So we will first divide our data set into two parts. One is a training set and another is a testing set. So basically, we generally divide each category into two halves. Okay, that generation is random in nature. So basically, we take 50% of the data randomly as a training set and 50% as a testing set. So what we will be doing is we will be using the training set to train our neural network model, and then we will be using testing set to to compute the accuracy of classifying images on the testing set. Okay, so basically, in the neural network, there will be labels or ground truth which says that what an image contains. So for example, this first image contains an aeroplane. Okay, the first image in the last row contains a truck. So this labels or the ground truth tells us about the data, what that data actually contains. Okay, so basically this training and testing split is random in nature. We are creating two sets, training set and the testing set. So where, let's say, if we are talking about training set, there are two parts. One is X train and one is Y train. X train contains your data, that means the images, and Y train contains the associated labels. So labels means, so for example, if we have an image in X train, the Y train, the one entry in Y train corresponding to that image will tell what that image contains. Similarly, for the testing set, we will be having two parts, X test and Y test. Y test is the labels of the images in X text. Okay, so we will see how to use this X train and X test to perform classification in neural networks. So we'll be using Keras. So let's just first see how to load a data set, or we can say existing data set in Keras. So to do that, what we will be doing is we will be using the package keras.dataset, and then we will be importing cfart and dataset. So the cfart and dataset is the dataset that I showed you in the previous slide. So to load the data set in Keras is very simple. We just have to use cfart10 dot load data. So it will simply return the split of the training and the testing. So it will return X train, Y train, X test, and Y test. Okay, and then what we have to do is we have to normalize the data set into 0 to 1 range. So for example, images are in range from 0 to 255. So instead of using that range, we just normalize every image in range from 0 to 1. And then so basically, we also the string labels into integers. So for example, for each of the Y train value, Y train contains, we will be assigning the integer values to it. So from 0 to 9. Okay, so because there are 10 categories. Okay, so we will be converting the class vectors to binary class matrices. So basically here we are also converting it into a matrix. So for example, let's say if we are talking about aeroplane, which is the first class, so it will be a one hot vector 1 0 0 0 till the last value. So it will be very clear when I will be showing you the code. Okay, so let's just now proceed with the introduction to neural networks and how to implement those. So before proceeding with the neural network, let's just see what is a perceptron. So perceptron is nothing but a computational unit, okay, which takes n inputs, and then we multiply each input with a specific weight. Then the perceptron computes the weighted sum of these input values. So let's say if our input size is of length n, we are giving an input vector of size n plus 1, and then we are computing the weighted sum using this perceptron, using this computational unit. So this extra n plus 1 variable is used as a bias. We will see what is the role of bias in the next lecture. Then the output of this some function is given to the activation function. Activation function is nothing but it just changes the or modifies the range of the output of the weighted sum. So for example, the most commonly used activation functions are ReLU and softmax. The ReLU changes the range from 0 to n. Okay, so that means it removes the negative values. Softmax is commonly used for classification problems where it transforms the output of the neural network into probabilities. So then the output of the activation function is considered as the output. So the output could be in some range, let's say from 0 to 1. So that means it could be probabilities. It could be a category. So for example, we can say, okay, it's a cat or dog, it's a face or no face, it's an aeroplane, it's a car, like that. Okay, so basically, like, we will see how to take that decision. This will come from the probabilities only, but we will see how to take that decision in one of the future slides. So it could also be a real value. So that means it can return a particular value that we can use as the output. Okay, so this was the introduction to Perceptron. Now let's just see how we use this Perceptron to create a neural network. Before that, so the Perceptron is a computational unit which contains the weighted sum and the activation function. So let's just make a 3-layer neural network. So a perceptron is nothing but the weighted sum and the activation function. So what we have done is we have created one layer which contains 3 perceptrons. So what we will be doing is, to create a 3-layer neural network, we will be adding more layers. So these are 2 layers. So this is the input layer. Okay, so what we will be doing is we will be multiplying each element of the previous layer to each perceptron. So for example, in this case, every perceptron takes the input of the previous layer and it will compute the weighted sum and then will apply the activation function. Similarly, for all layers, it will happen in the same way. And then we will be computing the output as a similar way as we did in the previous slide, or for the perceptron. So the output could be any specific case that we have seen in the previous slide. So now, what is a deep neural network? So deep neural network is nothing but when we stack multiple layers together. So for example, one layer, okay, so this is the input, 1 layer, 2 layer, 3 layer, 4 layer, like we will just add so many layers to make it deep. So that means we are doing a lot of computation to compute the output from the input. Okay, so this is a deep neural network. So in Keras, what we will be doing is we will be using the keras.layers package, in which we have a function called dance, which helps us to code this one particular layer of the neural network. So basically, one layer of this network is called as a dance layer, a fully connected layer, or a linear layer. In Keras, what we will be doing is we will be using this dense function, which says that how many number of nodes are there in that layer. There are 3 nodes. That means 3 perceptrons are there. And what is the activation function that we are using with that perceptron? So the activation we are using is ReLU. So we'll see how to code that. So before that, let's just see like whatever we have done. So let's just try to code it in Keras. So let's say this is the neural network that we want to code. So to do that, what we will be doing is we will first import Tensorflow, and then from Tensorflow we will import Keras. So we'll be using keras.sequential, which creates an object of the sequential class, which says that, okay, we will be creating a sequential model. Okay, and then so we have an input layer with 2 nodes. And then we have two hidden layers, which has 3 nodes each, and then there is one node at the output layer. So basically what we have done is, we have like showed that like there is an input of size 2, and then we have created a layer with three perceptrons, and the activation that we have used is ReLU. So basically only on the first layer we need to specify the input shape, and for the other sequential layers the input size is taken automatically from the previous layer. So then for the second layer we will add another dense function which says that 3 perceptrons are there, and then the activation is ReLU. And then the output layer is having 1 perceptron and the activation is ReLU. Okay, so this is how we will code a neural network in Keras, and then let's just see how to train it. So to set up the training, let's just first see a small procedure. So let's say we are giving a cat image to the neural network. It says that it's a dog. That means it's an error. Then what we will be doing is we will be using the actual label. That means the ground truth. What does that image contains? That image contains cat. So what we will be doing is we will be using the ground truth label and the output of the neural network to compute a loss function or the error function. So the most commonly used loss functions in neural networks is cross entropy loss, which is commonly used for classification, mean squared loss, which is used for mostly for regression, L1 loss, and there are many more. For example, KL divergence and like that. Then what we will be doing is we will be using an optimizer to backpropagate the error to the neural network to say to each perceptron that this much error has encoded in the end and in the output. So we will accordingly modify the weight of each particular perceptron. So basically how this backpropagation works is by using stochastic gradient descent. In this lecture, we will not be going in the mathematical details, but we will be using the function calls. So the most commonly used optimizers are ADAM, AdaGrad, RMS-Prop, stochastic gradient descent, and more. There are many more. Okay, so the most commonly used and the optimizer that gives the highest accuracy is the ADAM. So we commonly use ADAM, but in some cases RMS-Prop and AdaGrad also performs better. So to write this in the code, so what we will be doing is we will be using model.compile method, and we will be specifying the loss, the optimizer, and the metrics that we will be using. So the loss, that means for cat versus dog classification, we will be using categorical cross entropy loss. That is commonly used for two-class classification or multi-class classification. So optimizer that we are using is ADAM, and the matrix is the accuracy. We will see why we have included matrix here in one of the next slide. Okay, so to train the model, what we will be doing is we will be using model.fixed function, and then we will be specifying our input data. So we have loaded our input data into X-train and Y-train. So that means we have given the data and the corresponding labels. Then we will be giving a batch size. That means in one pass of the neural network, how many images will be used. So that means one pass from input to output will use 64 images. So that's why we are using GPUs, which performs parallel computation, and the training of the neural networks becomes possible in real time. And the epochs means how many times we will be running this training loop. So for example, we will be using 64 images in one pass, and then we will be computing the whole data set. So this is one epoch. And then we will be redoing this operation 30 times. So we will be shuffling the input data for doing this thing. And then the validation data is the testing data that we are giving as the input, so which will be used to compute the accuracy. That means how good the training has performed. Okay, so this was the training, and let's just see it in in a single page. So what we have done is we have imported the Keras. It's just 2-line code, and then we will load the data set that I have showed you in the previous slide. We will be like initializing the model using Keras.sequential, and then we will be adding different layers that I've showed you in one of the previous slide. And then what we will be doing is we will be specifying the training parameters, like what loss we will be using, what optimizer we will be using, and how we will be computing the metrics. Okay, and then to train the model, we will be using model.fit function, and we will specify the input and the validation data to this function. Okay, so this is how we train the neural network. So this was a simple introduction to the neural networks with common data. I have showed you an example of an input of size 2. Now let's just see how to work with the images in neural networks. So before going with it, let's just see what is an image. Image is nothing but a 3D array of numbers. Okay, so these numbers are in the range from 0 to 255. That means this is a cat's image, but to the computer, it is only a 3D array of numbers. So that means, like, if we zoom into this part of the image, so we will just see the numbers. Each number is in the range from 0 to 255. So for example, let's say we have an image of size 300 cross 100 cross 3. So 300 cross 100 is the height and width of the image, and cross 3 is the channels. That means RGB, color channels. So each channel has the range from 0 to 255. 1 pixel is a combination of these 3 colors. It could be, if it's a grayscale image, it will be one value. If it's a RGB image, so each pixel has 3 values for each channel R, G, and B. So let's say if we use these numbers as the input to the neural network, so how many inputs that we will be giving? We will be giving 90,000 inputs to the neural network. So that means if we are using, let's say 100 perceptrons at the next layer, so that means the number of weights that we will be doing in one layer are, it's 90 million multiplications are there. So it is a large number of computations. Okay, so before going to see how we can resolve that limitation, so let's just see what is like an image. So basically, let's say if earlier we were seeing the image from the left side, if we go to the right side, the image will look similar to us, but all the pixel values will change. So that means if we are using the approach of the previous slide, that means each pixel value is given as the input to the neural network, it is going to be highly erroneous because image pixel values changes a lot. So that's why instead of relying on the pixel values, we should be relying on the representations. So how to compute the representations for images is by using convolution neural networks. Okay, so what is a convolution neural network? So it is nothing but just a filtering operation on smaller parts of the image. So let's say this light blue is the actual image. So what we'll be doing is we will be taking a small window in that, let's say 3x3 window. We will be like computing a weighted sum with a few weights, and then we will be computing a small value with it. Okay, so I will show you how this actually works with a slideshow. But let's just first see, right? What we will be doing is we will be sliding over to the whole image, and then we will be computing each output of the next layer. So that means if we are giving an image as the input, what we will be doing is at the next layer we will be getting a smaller image. Okay, so we will be repeating it for the whole image. Okay, so this is how we will be computing the convolution. So let's just see how this convolution operation works. So let's say we are using a 3x3 filter of this 101 0 1 0 1 0 1. It need not be 0 and 1. It could be any real value as well from 0 to 1. Okay, so what we will be doing is we will be applying this filter to whole image. Let's say this is the green is the image, yellow is our filter, and then we will be repeating it over whole image like I have showed you in the previous slide, and then we will be computing the output. So the output is a convolute feature, which is this. Okay, so another operation for representation of images in neural networks is max pooling operation, which is used to reduce the size of the image. So what we will be doing is, let's say if we are using max pooling, what we will be doing is we will pick a small window. Let's say we have picked a 2x2 window, and what we will be doing is in max pooling we will be taking the maximum value. So for example, in this pink value of the first 2x2 box, we will be taking the maximum value, which is 20. The next light yellow is 30. So we will be doing this. So in max pooling, we will take the maximum value of a block. So in comparison to it, we can also use average pooling, where we are taking the average of a block to compute the output. Okay, so these are the two operations. The convolution operation and the pooling operation are used for representation of images into smaller size. Okay, so how to use CNNs for image classification? What we will be doing is, so we will be using it in this way. Okay, so let's say this is the input image, which is of a bird. Then what we will be using is, we will be using convolution operation plus non-linearity, means the filters or the activation functions that we are using. Okay, so for each of the window in the input image, we will be computing a small representation of it, and then we will be using multiple filters to compute the multiple copies of the input image. Okay, and then we will be using max pooling operation to reduce the size of this filter, and then we will repeat this operation a few number of times. Okay, I have shown it only once for representation purposes. And then what we will be using is, we will be using our previous approach of neural networks. That means we will be using fully connected layers or dense layers to perform the classification. So let's say if we are using CIFAR 10 dataset, so we will be having 10 categories, and we will classify the input into categories like bird, sunset, dog, cat, and so on. Okay, so to code neural networks in Keras is very simple. What we will be doing is, we will be using model.add and the layer. So the layer is keras.layers.convolution2D. So con2D is a 2D convolution operation. We can also use 3D convolution for 4D data. Okay, so this is commonly used for videos. Okay, so what we are doing is, we are saying that we are using 5 filters. So 5 means like in the image you are seeing that there are 5 filters in the first layer. So we have said 5. 3x3 is the filter size, and the input shape is 32x32x3. And the activation that we have used is ReLU. So to add the max pooling layer is also very simple. We will use keras.layers.maxpooling2D, and then the pool size is 2x2. Okay, so and then the addition of fully connected layers is very simple, that I have showed you in the previous slide. So I will show you it in Colab, like how to work with it. Okay, so one important operation is saving and loading a model. Okay, so to save a model, what we will be doing is, we will first need to convert it into a JSON object. So which specify the structure of the object. For example, for each layer, for each node, what is the weight. So we store it in a JSON form. And then this path is nothing but a Python package which will load this file. Okay, and then we will use f.write text. We'll write the JSON file. Okay, we will also save the weights separately. So this JSON model structure only contains the structure of the model, and the actual weights will be saved in the h5.h5 format, which is a compressed file. Okay, so we will be using model.saveweights and the file name. Okay, so to load a model is also very simple. What we will be doing is, we will load the file where the model structure is there, and then we will load f.read text as the model structure, and then model from JSON is loaded into the model, and then we will load the weights using model.loadWeights and the file where the weights are written. Okay, so I have shown you like how to perform like 2-class classification, like only one node was there earlier. So now let's just say if you want to perform 3-class classification, how to do that. So let's say our 3 classes are cat, dog, and frog. So what we'll be doing, let's say our model is same as we have used earlier. So to do 3-class classification, earlier we have done only like 2 class we can do on from one node as well. But let's say to perform 3-class classification, we will be adding 3 nodes. That means 3 perceptrons at the output layer. Okay, and then we can use softmax activation here to compute the probabilities from these three values. So for example, let's say if the probability for cat is coming zero point 0.9, for dog 0.1, no, sorry, 0.05, and for 0.05, that means highest probability that the input contains cat. Okay, so this is how we will be performing multi-class classification. Okay, so how to perform prediction using neural networks? Earlier, till now, we have just seen how to train the neural network. Now let's just see how to perform the prediction. So what we'll be using is we need to first load the image into the actual size which we have used during the training. So what we will be using is we will be using image.load image. So basically, load image is nothing but a function from Keras only. Okay, so we will be loading an image that's a cat.jpg, and the target size will be 32 cross 32. So why I have used 32 cross 32? Because I have trained CFAR 10 with images on 32 cross 32. CFAR 10 is actually contains images which are in size 32 cross 32. Then what we will be doing is we will be converting this image into NumPy array, and then this is the image. So basically, an image is a three-dimensional vector. But in Keras, we need to provide four dimensions. The first dimension is the number of images. So basically, it takes a batch. So a batch is a 4D vector, or we can say a 4D tensor. The first dimension says number of images, second dimension width, third dimension height, fourth dimension is the number of channels. So that means B, number of batches, and cross W cross H cross 3 if there are three channels. So that means we are expanding the dimension, and we will add 1 to the 0 dimension. That means the input image will become 1 cross 32 cross 32 cross 3. Okay, so to do prediction, it's very simple. Like we will just use model.predict and the list of images. So it will return the output. So we will take the first output, and so basically, like in Keras, we will be computing like argmax means the which of the value in the output result has the maximum value. That means the maximum probability. Okay, and then we will assign the class labels in this way. So basically this will not be clear in this slide, but I will show it in the code how to do it. Okay, so let's just move to the code, how to perform it in the code. Okay, so let me just share the code. Okay, so this is the code. Okay. Okay, I hope you all can see it. So just a minute, let me just share it. Okay, so this is my collab notebook. So where what I have done is I have basically I will be using Google Drive to access images and the code. Let me just run it. I think it's already loaded. It's already mounted. That means okay, it's not mounted. Let me just mount it. Okay, so just a second, it's taking some time. Why it's taking so much time? Okay, let me just redo it. Okay, so it's done. So basically, it will ask for authorization code. I have just entered the authorization code. And then I will change my working directory to the location where my files are placed. Okay, so it's taking some time. I'm not sure why. Yeah, I think it's done. Okay, so these are the files that are placed in this location. Okay, so we will be seeing this getting started with neural networks, and we will be using fine tuning VGG16 for image recognition in the next lecture, where we will be doing mask and no mask classification. Okay, so you can do TensorFlow GPU installation using this file. So using this command, and I have shown how to train the neural network in the slides. So I will be skipping this. So to train CIFAR 10, what we will be doing is we will import Keras, and Keras from Keras data set we will be importing CIFAR 10, and like these are the other like functions that we have seen in the slides, and then we will be using those. Okay. So first we will be loading CIFAR 10 dataset. Okay. So we will be normalizing it and we will be converting it to the categorical input. Okay. So this is how we can go with it. Okay, so it's downloaded. So this is how we will be like creating a deep neural network. So in the slides, I've shown you a very small neural network. So now what I have done is I have just created model.sequential. So basically in slides, I wrote keras.sequential. Here I can simply write sequential because I have already imported sequential here. If you don't write these lines, so you have to write keras.sequential. I think this is obvious with you all. Okay, so what I have done is I have added so many convolution layers and pooling layers. So the first layer has 32 filters of size 3 cross 3. Okay, the input size is 32 cross 32 cross 3. The input is used as ReLU every time. Okay, and then I've added one more convolution layer, and then I've added a pooling layer. Okay, I have added another convolution layer with 64 kernels, and then one more, and then pooling layer. So I have also used a dropout. Dropout is nothing like, I think I skipped it in from the slides. Like it is nothing but what it says that okay, only 25% of the perceptrons at that particular layer will be active for the next layer. Okay, so that means it is doing some regularization, which is found to be very effective to stop overfitting in neural networks. So then what we will be doing is, so the output of this function, this max pooling layer, is a 2D or like we can say 3D matrix or 3D tensor, I mean to say. So what we have to do is we have to create it into an array. Okay, so we will be using like flatten for this. Okay, so flatten, what it will do is it will create it into the 1D tensor. Okay, and then we will be using two dense layers of size 512, and the output layer has the 10 perceptrons with activation softmax. So basically that means at the output layer we will be seeing 10 probabilities. So to specify the training parameters, we will be using model.compile, where I specified that we will be using categorical cross entropy as the loss and Adam as the optimizer, and we will be using accuracy to compute like the performance of the network. Okay, so model.fit is used to train it. So let's just run it. Okay, so let's just run it for only 4 epochs. Okay, or maybe 2 epochs, because like let's just save time. I think you can run it for 20, and it will give you good performance. Okay, so I'm not sure if it will work on GPU, but okay, so if it is slow, it will work on CPU. Okay, it is working on GPU, I guess. Okay, so I have specified that in each batch there will be 64 images, so it is incrementing with 64 images. Okay, so you can see that in the first epoch, the validation accuracy accuracy was 56%, and in the second it was 67%. When I run it for, let's say, 20 epochs, it will go to a very good value. Okay, so to test it, so we will be using like the thing that I have specified in the slides. So we will be loading the image first in the target size, and then we will be expanding the dimension. We will be using model.predict. Okay, and then it will say the output. Okay, so I've just printed like what it says. Let's just say I have specified dog.png as the input image. So okay, so it says that okay, the image is truck with likelihood 1. So it is saying this has truck because the model has not trained yet. So if you see that okay, it has only 60% accuracy, so that's why it has a error. So maybe let's just train it for maybe 3 more epochs. Okay, so it will take some time. Have patience. So basically, it will resume from the previous like training only. Okay, so let's just see what it says now. Okay, it still says struck. Oh, okay. Earlier I trained it for 20 and it worked well. So let's just see. I'm running it for 5 more epochs. So okay, so I think okay, the validation accuracy is at 76%. Okay, and the training accuracy is 75. So it's still like somewhere in between. Okay, we are still at 77. Like we have to run it for more. Okay, training accuracy has gone to 80, but it is at 77 yet. Okay, so I think it will still say truck, but like okay, now it is saying horse. So that means training has changed, like from the previous epoch. But like if you will run it for 40 epochs, it will surely like or 20 epochs, it will surely give you a good performance with the network that I have made. So this was it for training a neural network for image classification. Okay, so I have just shown you an introduction. So in the next lecture, let me just show you the lecture. Okay, so where we will be performing image recognition. Okay, so I will be talking about more stuff like pre-trained neural networks, like how to use pre-trained models and how to like fine-tune the existing models. So for example, like the networks that which are available for cat dog classification, how will you use it for mask and no mask classification? So these kind of fine-tuning I mean, and like we will also be like seeing a take-home exercise where you can see like how to do mask no mask classification or maybe like some digit classification kind of stuff. Okay, so like we will see this in the next lecture. So like I'm leaving today here only because like it's already more than 40-45 minutes. Now I will take a few questions and then maybe on Thursday or on Saturday we will like complete this tutorial. Okay, so where we will talk about more a few advanced stuff. Okay, and there is one more thing that please join our WhatsApp or Telegram group. Okay, so that you can get notifications about such tutorials. Okay, so let me just see a few questions. Not visible. Yes, we will upload this. Good evening to all. Data files. How training sets are given? How training sets are given? I'm not sure what do you mean by how training sets are given. Uh, okay, so how training sets are given? I mean, I think you mean that like I think okay, WhatsApp group link. Maybe let me just show you on the slides. Let me just show you on the slides. Maybe you can join our Telegram group. So basically, like this is our Telegram group. So you can join this, and like so we will more notifications about like how to do mask, no mask classification, how to do object detection, how to do object recognition, and how to do face recognition kind of stuff. Okay, so also subscribe our YouTube channel. So we will be adding some offline lectures as well, which have been completed earlier, and we will also like be giving our future lectures here on YouTube live. Okay, so this is a Telegram group, so which you can join, and like so I think like we can't paste it on the comment section because screen not visible. Oh, sorry for that. Let me just. So I think it's visible now, right? Yeah. So please join this Telegram group because we can't paste it here on YouTube. Like YouTube doesn't allow to send like these WhatsApp and Telegram groups. So maybe just like it will be a little inconvenient, but let's just uh, ping it. Like just type it on browser or like just send me an email. I will send you the link. Okay. So my work profile is available on this web page, and you can go for it. Okay, so this is my website. Okay, and you can contact me on this email. So if there are a few questions, and like so if there is any question, please feel free to ask. I see no question here. Okay, so this is the Telegram link, group link. You may join it. And also this tutorial will be saved for future reference. So you can like use the link that is shared with you to watch it again and again. How can we integrate this ML with MERN website projects? I'm not sure what do you mean by MERN. Can you tell me more about MERN? So do subscribe our YouTube channel, please. Tell what is Mon website project. I'm not sure what it is. So maybe what you can do is you can ask me this question on my email or on the Telegram admin to the Telegram admin. I will try to answer your question. So I think there are no more questions. So let's just stop this tutorial part here. So in the next tutorial we will be completing this part. So where we will be talking about more advanced stuff like how to perform image recognition using pre-trained models, and from the like how to fine tune the like the existing models to our problem. So example, we will upload an image to detect what it is. In the back end, we will use one website like MongoDB Node.js. Yeah. So basically, what you can do is, so basically, you need a high computing device. So, for example, a GPU. But what you can do is, instead of Node.js, maybe you can use TensorFlow.js, okay, like which provides a JavaScript access to do it to do this image classification in TensorFlow and JavaScript. Okay, so basically, it will run live on your really advanced version to computations, metrics computations for on one browsers. Okay, I hope I have answered your question. So if there are more questions, please feel free to ask on email. So we can like answer your questions there, and do join our Telegram link, Telegram group, I mean to say, and we will give you like details about future tutorials there only. Okay. So then, okay, see you. I think I'm done here. Okay, thanks for attending the session. See you in the next tutorial. Bye bye.